I'm going to start the review by drawing a little triangle here. That's the triangle that allows you to convert between polar and rectangular. It'd be a lot easier to just give it to you, but you're supposed to remember. And if you jog your memory and it's not there, it'll help it to stick better in a second. Try to draw that triangle that helps you to convert between polar and rectangular. The easy thing would have been to give it to you. Do you remember? Nope. Thank you for asking. It's a good guess. What does it have in it? It has a 90. You know that for sure. I'll give you that. That's an easy one. Tyler? This is X because that's in the X direction. This is Y because that's in the Y direction. And this is a theta, and that's correct too. But can you tell me the last thing that's in it, Sophia? R. That allows you to convert. Why? Because it's got X's and Y's and R's and thetas all in one spot. Okay, so then there's 4 things that you can get out of this. You can use cosine. You can use sine. You can use x squared plus y squared. And then you can do tangent. So it's about sine, cosine, and tangent. And write out those 4 facts. These are the identities for this unit. If you're struggling with what is he talking about, sine of theta equals something, you can look at the triangle and figure that out, and then you'll be able to use that to convert between polar and rectangular. What is sine of theta equal to? Do you remember? Olivia? Nope, it's y over, sine is opposite over hypotenuse, y over r. And then you can solve that pretty quickly. What do we do to solve it, Max? And look at that, y equals r sine theta. Raise your hand if you have r sine theta on your list. Okay. Val, can you tell me something about cosine? And then solve it for me. By timesing by what? And what do you get? Yep. That's 2 things you can use to convert. Wherever you see an x, you can put an r cosine theta. All right? Give me the next one. I'd like you to say that, except say it with x squared plus y squared. And then you did something nifty, and you solved it for r. Can you do that again? Yep. Do you have to do it that way? No. But if you just had a single r, you could replace it with this. R is the square root of x squared plus y squared. Okay, and then there's one last one. Sine, cosine, and what's the last sentence? Type. Tangent. So tell me that one. Tangent of theta. You got this. TOA, opposite over adjacent. Opposite over adjacent. Y over x. And you might be thinking, well, where's the r? Well, we don't need an r because this one is a theta changing over to a y and an x. All right, so tangent is y over x, and that's it. And you don't have to solve that one. TOA is opposites from this over adjacent to this. Okay, and those are the big ones that you can use to then do conversions. So here's a typical convert problem. R equals 5. Convert that to rectangular. Would you agree it's in polar right now? So, Alec, how do you convert that over to rectangular?
try?
I kind of get where you're going with that, but there's a lot easier way. I'm going to give you two choices. What sounds more logical for this problem? Should we multiply both sides by r, which does give us an r squared? Or should we square both sides, which would also give us an r squared? Because r squared is equal to x squared plus y squared. So you should be going, how can I get an r squared in this thing? So what do you think we should do, Alec?
R squared.
Yep, square it. It's easier. Because r squared is done, boom, it's r squared. And then that's x squared plus y squared. And 5 squared is 25. And that is about as easy and clean as you can get. And that's the equation for a circle with a radius of 5. So I hope that makes sense to you. Okay, so that's a conversion between polar and rectangular. This one's polar because it's got r's and thetas. This one's rectangular because it's got x's and y's. So here's another option. R equals 4 cosine theta. This time, if I want to change this over, because right now it's got r's and thetas, so it's in what? Polar. And I want to change to rectangular. This time, squaring both sides is going to be a pain. So, what's another alternative? Instead of squaring, you can times by something. That's my hint. Okay. Times by, well, if you want this to be r squared, you could times by r, and you might be thinking, isn't that the same as squaring? Kind of. But if I times this by r, I'm going to put the r right there, strategically. You see how that's kind of cool? I get my r squared, but I also get an r cosine theta. So don't just think you always square both sides if there's an r. No, sometimes you times by r on both sides. Okay, then I get r squared equals 4r cosine theta. Have you seen both of those before, Teddy? What's r squared?
You do x squared plus y squared.
X squared plus y squared. And then what's the r cosine theta?
That's going to be x.
Yep.
Yeah.
Look at that. Does that only have x's and y's in it? Yep. So then it's done. Yes?
If it said simplify, would you like get all of
If it wouldn't say to simplify. The only thing it would say is, sometimes, it'll say solve for r. Why? Because if you want to graph it, you'd have to have r equals blah, blah, blah. Okay? So solve for r is a common thing. Sometimes they could say solve for y, but that'd be more rare. But let's say I had to solve for y. Do you get I would subtract x squared from both sides? And then I'd just take the square root of both sides. It wouldn't be like impossible to solve for y. Okay. All right. So how about intersections? R equals cosine theta. First of all, you should kind of know what that looks like. I taught you this on that little day where you stayed at home on Monday, and I had a 4.5-minute video. Do you remember what the graph of r cosine theta is? Yeah, you can make a chart and everything, but you shouldn't. It's a little circle somewhere. Do you remember where? How many of you think you remember where? At least you have a better than 50-50 that you think it's somewhere. What do you say? So, okay, I'll start at the origin. So where does it go from there? So do you believe that it's the blue one, or do you believe it's the red one? The blue one. Raise your hand if you kind of knew it was over there. Okay, good. So now I know that my graph looks like this blue one here. And if I wanted that to intersect with r equals 6, too bad, because it's not gonna. Do you get r equals 6 would be like this? You get they would never intersect? Okay. And why? Well, watch what happens when I put in substitution, r equals 6 right here. 6 equals cosine. Does cosine ever equal 6? Think about the graph of cosine. What's the highest cosine ever went? Only goes up to 1, and the lowest it ever went, -1. It's never going to get to 6. That's why that doesn't work. But when you have r equals cosine theta, and then r equals 1, yeah, you could draw it out, and try to figure out where they cross on the polar graph. That would be a really slow way to do it, but you could. It wouldn't be illegal. You'd have to graph the first one and then graph r equals 1. And, oh, interesting. Look at that. You can see, do you see that they touch? And if you're good at, like, understanding my rough drawing here, they would have to touch right there. But let's solve it this way. 1 goes here. 1 equals cosine theta. Would you please solve that some other way? All right, so then this is circle trig. And you can't draw a triangle for this, so then you go cosine is x. Oh yeah, x is supposed to be 1. X is 1. That's at this spot right here. And then you get the angle, and it's 0 or 2 pi. Whenever you're faced with the choice between 0 or 2 pi, always pick 0. It's smaller and easier. And usually, if there's requirements on the problem, they usually say it can't be 2 pi, but it can be 0. Okay, so if you're picking between 0 and 2 pi, say 0. Okay, so the answer is 0. No, it's a point. That's a point. And it's got an r and it's got a theta. Please figure out what point that is. I figured out the angle, but I didn't figure out the other part. The answer is not just 0. Do you get how a kid could just figure out the angle and they're like, yay, I figured out the answer? No, it's r comma theta, and they figured out theta is 0, but the r is 1, 1 comma 0. Raise your hand if you had that one right. Okay, good. Let's do another one. It's a little more complicated. 2 equals r, and r equals 4 sine of theta. Would these two intersect? Spoiler alert, yes. Now you figure out where. I'll pause for a second while you give that one a try. All right, so if I put the r equals 2 right here, then I have a 2. Why did I do that? Because r equals 2, so I put a 2 where r was. Then I divide both sides by 4. And why did I do that? Because I'm trying to get the theta alone. 2/4 is 1/2. 1/2 equals sine theta. Then, if I want to solve that, it goes back to circle trig. Did I say that would be an important test? And it keeps coming back. Can you do the circle trig for this? Where is sine positive? Sine is positive on the top. So it's not here and it's not here. And if I was going to draw my triangles, it'd go like this. Sine is opposite, hypotenuse. Square root of 3, but negative. Most common mistake in circle trig. And then that helps me remember that what's across from the 1 is the 30-degree angle. So this is pi over 6, and this is 5 pi over 6. And the kid writes that, and I cry a little bit and mark it wrong. It's not really wrong, but it's not done. Because the question was, where do they intersect? And you can't just say pi over 6 and 5 pi over 6. If you were one of the people that messed that up, please write the answers as points. Something comma something. And that'll help you remember that it's not just the angles you were looking for. Who actually is right so far? All right. So, Oscar, what do you think the final answer is?
2 pi over 6.
Yup.
And 2 pi over 6.
You got it. All right, if we looked at the graph for that, what do you think 4 sine theta looks like? Well, if sine theta looks just like a circle that's on the top, 4 sine theta is probably just going to be a bigger circle that's on the top. And then r equals 2 was the other equation. Well, that's going to kind of look like this. And you see how I end up with 2 points? Why do they have a radius of 2? Because they're on this circle that has a radius of 2. That only makes sense. And why are those two angles what they are? Well, look, there they are. Okay, I think that's enough practice of that. We've talked about converting things from rectangular to polar. We've talked about intersection points between the two. Now we got to talk about graphing. Okay, so let's say I asked you to graph something. Here's what you'd have to do in the middle of that problem. Sine 0, sine of pi over 2, sine of pi over 3, sine of pi. You got to be able to do these like riding a bike. You got to be able to be, oh, that's easy. I just jump on and I ride. No big deal. Would you please figure out what those 4 answers are? You might need to draw triangles. You might have this unit circle memorized. You might have some of these memorized, but not others. But just find those 4 answers. I'll show you why that pertains to graphing in a second. If you're like, what are you talking about? Just draw the picture. Sine of that. I said 0, but I put a theta thingy through it, so I apologize for that. It's just 0. Sine of 0. So here's 0 degrees. You're supposed to be able to tell what the sine of 0 is by looking at that unit circle. All right, I'll be quiet for a minute while you finish this. So we'll start with these two. The student said that the answers are 0 for this one and 1 for that one. If this point right here is important, it's 1, 0, and then sine is the y of it. So that's this part, right? So then we're good on that. And then this one's 0, 1, and then it's the y of it. So that's 0 and 1, your first 2 answers. So then how about sine of pi over 3? It's the first one that's different. Well, here's where pi over 3 is. Pi over 3 is like a 60-degree angle. Okay, so if that's 60, then this is 30, and then this is the 30, 60, 90. And then across from the 30 is the 1, and then the 2, and then the square root of 3. It's easy to mess up which one you're across from. Okay, so then I just set that all up for you. Can you tell me what the sine of pi over 3 is then? Square root of 3 over 2. Good. And then the last one?
0.
And that's negative 1, 0, and it's the y of it, so it's 0. All right. Now, when would you ever use that? If you were graphing, let's just keep these up on the same screen here. If you were graphing r equals 3 sine of theta, you would need to have figured out a bunch of things for r and theta, except you usually don't put in the r's, you usually put in the thetas. And so effectively, I just put in 0, pi over 2, pi over 3, and pi. Are those the only possible things? No, I could have put in anything. I could put any angle I want. Just like on graphing x and y's, you could put in any x you want and figure out the y. Okay, so would you please finish this then? And we're just going to throw in one more. I'd like you to do pi over 4. So you're trying to figure out from this equation, what will r be when you put in those different angles? We already got the answers for sine of theta over here. I'll pause for a second. Okay, so here's how this one would work. You have figured out that sine of 0 is 0. So then that means when you put in a 0 here, you'd get 0, and 0 times 3 is 0. So r would have to equal 0. Next, pi over 2 was 1. So I put a 1 right here, because sine of pi over 2 is 1, and then 3 times 1 is 3. All right, can you give me the next two, Opal?
So 3 square root of 3 over 2.
3 root 3 over 2. Perfect. Now, this does beg a question. If you had to graph this, you just have to estimate this? Would you agree that's a little bigger than 3 on the top? 3 root 3 is a little bigger than 3. So it might be like 4-ish. Okay, and then 4 over 2 is like 2. So if you were in the neighborhood of 2, I would have said that's probably fine for graphing. Because nobody knows exactly where 3 root 3 over 2 is, but we can get close. Okay. How about this? At a minimum, if it's 1.5 and then you times it by something bigger than 1, it's going to be bigger than 1.5. So I don't expect you to be perfect on these. Next one is pi. Sine of pi is 0. Opal, what did you get when you put a 0 in?
0.
3 times 0 is 0. And then how about the last one?
I got 3 over square root of 2.
Can anybody verify 3 over square root of 2? All right, just to clarify on that last one, we would do sine of pi over 4. How do you do that again? I draw a picture and I draw pi over 4, which is a 45, 45, 90, 1 root 2. And then I go sine of that as opposite over hypotenuse, and I get 1 over root 2. And then I take that 1 over root 2 and I stick it in for where sine was, and I get 3 times that. So that's 3 times 1 over root 2. So that's 3 over root 2. Very good. Okay, and if you're like, I don't know where that is, well, then maybe you could go 3 over root 2 and times by root 2 over root 2. We've done this a million times by now. And then this becomes root 4 on the bottom, which is 2. And then it's 3 root 2 over 2. That's like about 4-ish maybe. Something bigger than 3 anyway. So 4 over 2 is probably about 2. It's not exactly 2, or it would have simplified the 2, but just trying to give you an idea of how I could graph these. So then the actual graphing is, I hope, the easy part. So would everybody please just make a quick polar graph of this? And remember, anytime the radius is 0, you're at 0, 0. Doesn't matter what angle. If it's r is 0, then you're at the origin. Three comma pi over 2. This is pi over 2. And I go up 3. Put a dot there. So I get 2 dots so far. I said that was about maybe 2-ish. Pi over 3 is like this. It's out about 2-ish. Looks like there-ish. Okay. This one's back to the origin. Don't need to graph it again. It's already there. There's already a dot at the origin. 0 comma anything is at the origin. And last but not least, we figure out that's about 2 comma pi over 4. And pi over 4 is a 45-degree angle. So that's like a 45-degree angle. And so the last point, I'll make it blue here. And I go out in a radius of about 2. There-ish. Okay, now did I graph that perfectly? Of course not. In the end, do you get what this is supposed to look like? 3 sine theta. It's basically supposed to end up as a circle. And I missed a little bit. My black dot should have been a little bit further out. Okay. I think that's going to be the hardest one for you. That graphing kind. Wouldn't it be smart to practice one of those tonight? You think there might be one in the homework somewhere? Yes. It's like a million of them. There's one in the notes for today, too. Okay. So what else do we need to practice? Well, just plain old-fashioned changing polar to rectangular or back and forth. So if I said, here's a spot over 2 and up 1, would you agree that that is a rectangular point? But the problem with this one would be you wouldn't know the angle. Because it's not the 1, 2 square root of 3. That's not a thing. The biggest side has to be here, right? So this would actually be the square root of 2 squared plus 1 squared, which would be 4 plus 4 squared of 5. Okay, so we wouldn't probably give you that one because you wouldn't know the angle on the 1, 2 square root of 5 triangle. Okay, so what would we do? We'd do ones you probably know. Like what about if I made both of those 1? If I said this was 1 and 1, would you be able to tell what it is in rectangular? Well, it's 1 comma 1. What is it in polar though? And then find 4 ways to write that in polar. That'd be cruel if I'd never taught it to you before, but we've practiced this at least twice before. You're supposed to be able to find 4 ways. The first 2 ways are just like finding the angle, because it's r comma theta, and it won't be that hard to figure out this side here. And then the angle will be like, oh, I know this one. It's the 45, 45, 90 triangle. But then you'll have to use this shadow point over here. Don't forget that. pausing for a second. I'll give that one a try.
Square root of 2 pi over 4.
Good start.
Negative square root of 2 5 pi over 4.
Okay, I'm going to go over the shadow point because that's important, right? And that would be at regular square root of 2 comma 5 pi over 4. So that's where you got that one from, right?
Yeah.
You kind of did that except the opposite. So then it'd be negative root 2 5 pi over 4. Is that what you said?
Yeah.
Excellent. Keep going.
Square root of 2 negative 7 pi over 4.
And that's going around this way. Negative 7 pi over 4. I agree with that one. And then the last one?
Negative square root of 2 comma negative 3 pi over 4.
And that's really this spot. Negative 3 pi over 4. I agree. Nice job. Okay. Now, what if I gave you a point in polar? Let's say it's here. It's 4 comma 5 pi over 6. Can you tell me what it is in rectangular? Hint, draw a triangle, figure out the sides. That'll tell you what you need. Pausing. So this one's pretty easy if you know how to draw triangles. Now, how could they make it harder? Well, if they made the sides weird or the angles weird, then it's harder. Not impossible at all. But this one, I know this is 4. And then I know 5 pi over 6 this way meant that this was a 30. And if that's a 30-degree angle, this is the, oh, wait, I got to be able to do this 1, 2, square root of 3 triangle. And then I go, oh, this one's actually only 2 times bigger than the normal one. So I can just take all these numbers and double them. Now, if that doesn't work for you, you can just go 4 is, and let's call this X and this Y. I always say to start with the X or the Y. And I'd go X is to the square root of 3 as 4 is to 2. And then I know some of you are going to be like, it's just doubling the square root of 3. But see, this way would always work. And you won't have to have it be a nice number like doubling. Yeah, that does double the square root of 3. So 2 root 3. What's the most common mistake in circle trig? Negative 2 root 3. I'm sure a few of you got burned on that, but probably not too many. And then last but not least is this side, which if I'm really just doubling is a 2. So that's 2, and that's negative 2 root 3. So what's the point you're looking for? Negative 2 root 3, comma 2. Okay, that's rectangular to polar, and polar to rectangular, and all the different ways you can write polar. And man, we've covered a lot. So what would I do at this point? At this point, I would go and do all the practice problems that we have, and I would check them against answer keys. I would go back and look at previous problems and check them against answer keys. And that's your homework for tonight. Look for a drop box. That's all I got for you.